Let's talk a bit more about Helm charts. Helm is rather an easy to use command line tool. You just tell it to install this, uninstall that, upgrade something, roll back to a previous state, and so on, and it proceeds to do all the heavy lifting behind the scenes. It's basically an automation tool where we, the human operators, specify our desired end result, the destination, and then it doesn't matter if 5, 10, 20, or 50 actions are necessary to achieve that end result, to get to that destination. Helm will go through all the required steps without bothering us with the details. But since in the command line, we don't give this tool a lot of info except, hey, I want this installed, how does it know how to achieve this goal? Helm knows how to do its job with the help of what are called charts. Charts are like an instruction manual for it. By reading and interpreting their contents, it then knows exactly what it has to do to fulfill a user's request. As far as the human operators are concerned, charts are just a bunch of text files. Each specific file named in a specific way has a well-defined purpose. For example, as discussed before, in the values.yaml file, we'll find parameters that we can pass to the chart so that everything gets installed with the configuration options set as we desire. Now, we saw this simple example earlier. In this case, we have two objects, a deployment and a service. And it's a standard deployment that deploys pods of an image and a service that exposes it as a node port service. However, you might notice the image name and replicas are specified in a different form. This is called templating. The values that go here are part of the values.yaml file, and we will look into templating itself in more detail later in this course and how to form these values. So the two files are templates. These are customized using the values from the values.yaml file to create the final version of files required to deploy the application on the Kubernetes cluster. Apart from the values.yaml file, every chart also has a chart.yaml file. It contains information about the chart itself, such as the chart API version, which could be either v1 or v2. There's also an app version, which is used to specify the version of the application. And then we have the name of the chart, the description, type of chart, etc. And these are just a few of the many properties a chart.yaml file has. So that's what we will look at next. So let's look at the chart.yaml file of this WordPress site as an example to understand it better. The API version is the API version of the chart. Now, when helm2 was around, this field did not exist. And when helm3 was introduced, it came with the additional features that introduced changes in the YAML file, which were not present earlier. For example, the dependencies section and the type fields that you see here were not available in helm2. So helm3 needed a way to differentiate between charts built in the past and charts built for helm3. And so this field was first introduced by helm3. With this field, helm3 can now differentiate between old charts built for helm2 and new charts built specifically for helm3. So old charts will either not have this value set at all, or if you build a chart specifically for helm2 today, then it would need to be set to v1. And all charts built for helm3 will have this value set to v2. So let's say you build a chart with the API version set to v2, but use it on helm2, then helm2 will not even consider this field and will simply ignore any additional fields that were only available for helm3, resulting in unexpected results. So bottom line is, if you were developing a chart going forward, just make sure that you set this to v2 because you're most likely going to write charts for helm3. And if you're looking at a chart that does not have this value set, then it is very likely that the chart was built for helm2. Okay, so next is the app version. Now, the app version is the version of the application that's inside of this chart. So in this case, the application is WordPress. So this refers to the version of WordPress that this chart will deploy. This field is for informational purposes only. And then there is version, which is the version of the chart itself. So every chart must have its own version. And this is independent of the version of the app that this chart will deploy. This helps in tracking changes to the chart itself. The next is the name of the chart, which is set to WordPress, followed by a description. And the next is type. So there are two types of charts, application and library. So application is the default type, which is all the charts that we create for deploying applications. And library is a type of chart that provides utilities that help in building charts. So we'll discuss more about that later. The next are dependencies. So the WordPress application is a two-tier application that has the WordPress server and a database server. The database in this example is a MariaDB database. So MariaDB has its own Helm charts. So we could simply add it as a dependency to our application. This way, we don't have to merge the manifest files of MariaDB or any other database into this particular chart. And then there is a list of keywords associated with this project. This can be helpful when searching for this chart in a public chart repository. And then there is maintainers section, which is information about the maintainers. And there are optional fields like home and icon that are used to share a URL of the homepage of the project and a URL to an icon. So a chart directory has the following structure. It has a templates directory that has the template files that we just talked about. It also has the values.yaml and the chart.yaml file we just talked about. And apart from these, there may also be a license file that has the chart license information, a README file that has information about the chart in a human readable form. And there could also be a charts directory that has other charts that this chart is dependent upon. And we will talk about chart dependency later in this course. Well, that's all for now. I'll see you in the next one. With Helm installed, let's check out what we can do with it. All operations are run using the Helm command line interface. To invoke the Helm command line interface, simply run the Helm command. Simply running the Helm command, or running Helm with the Helm option, will list helpful information. This can serve as a quick way to remember what the right command is to do something. For example, say we want to restore a release to a previous version after a failed upgrade. We might wonder, wait, what was the command to do that? Helm restore? And we then see in this list that the correct command is actually Helm rollback. So it's much faster than looking on the internet for the answer since it's immediately accessible from the command line interface. We can also use this help feature for subcommands. For example, if we want to see what repository related actions we can take, the command helm repo help will show us how we can add chart repository or list chart repository or remove repository and so on. And we can even dig deeper and learn about what a subcommand does and what parameters it supports. So now that we are familiar with the basics of Helm CLI, let's see what we can do with it. So let's assume we are in a scenario where we need to launch a WordPress website in Kubernetes. And we know that we need a chart to easily deploy the WordPress application. So earlier we learned that all the charts are stored in the online chart repository at artifacthub.io. So we go to the website and search for the chart manually. To ensure we get a high quality chart, we can try to find one that has the official or a verified publisher badge. So once the chart is selected, we'll see a detailed page with all the info that we may want to know about this chart. So it starts out with the exact commands that we need to use to install the chart into our Kubernetes cluster, then continues with what software components this uses, and further down the page, we can even see some of the most important configurable settings that we can tweak. Now, it's up to chart developers to mention what they think is important in this description page. Another way to search for a chart is from the command line itself. Use the Helm search command to search for WordPress, but note that the search command expects an additional subcommand where you must specify where to search. So you must specify either hub or repo. Hub refers to the artifact hub, which we just saw. We know that the hub is where all the repositories are kind of listed. So this is going to list all charts listed at the artifact hub.io. However, if you'd like to search in specific repositories, then you could use the repo option. So here are the results that show a list of charts for deploying WordPress along with the app version, which by now we know is the version of the WordPress that these charts will deploy. Once we have identified the chart to install, we can deploy the application in two commands. As listed in the README file for that chart, there are two commands to be run. The first is to add the Bitnami repository. So the Bitnami chart repository is available at charts bitnami.com/bitnami. It must be added as a repository to our local Helm setup so that when we run the install command, Helm can find where the chart is to be installed from. The Helm repo add command adds the repository. Next, we deploy the application to our cluster using the Helm chart by running the command helm install my release Bitnami WordPress. So that's it. It's super simple. Deploying an application on a Kubernetes cluster has never been easier. At the end, we even get some useful information about how we can use this WordPress install. So this text is actually generated by the instructions included in the chart. So this way, users can get an idea about how they can continue with their newly installed Kubernetes package. Now, once a chart is deployed, it is deployed as a release. So to list all existing releases, run the helm list command. This is very useful, not only to track what has been installed, but also to see what hasn't been updated in a long time. Now, when we want to remove all traces of this app, imagine doing that by hand. We would have to delete a lot of objects from our cluster one by one to get rid of all the WordPress related components. But with Helm, this is again easily done with a simple command. Since we now have the name of the release, we can remove all Kubernetes objects added by the WordPress website with one simple command. Again, very easy. We can really begin to see the power of Helm as a package manager for Kubernetes. Now let's look at some of the other commands available while working with Helm repositories. So the Helm repo command can be used to add, list, remove, or update Helm repositories. So we already saw the Helm repo add command. The Helm repo list command lists existing repositories. The Helm repo update command is somewhat equivalent to what a sudo apt-get update command does on some Linux-based operating systems. So in a nutshell, the info that Helm has about that repository is stored locally. And with time, repository maintainers make changes, update stuff, and so on. So our local copy of this info gets stale and outdated. So the command above refreshes the info that Helm has by pulling it in from the online repository to our local computer. This way, we get the latest data available. Well, that's all for now. Head over to the labs and get your hands dirty with some of the basic Helm command line operations, and I'll see you in the next one. Let us now look at how to customize chart parameters while installing a chart. When we installed WordPress, we installed everything with its default value. But we may not want to do that at all times. For example, the blog has a default name called users blog. We may not want our WordPress site to have this name. So how did it get this name in the first place? The WordPress application deployed by the deployment.yaml file has a WordPress blog name value set as environment variable, and it picks the value from the values.yaml file, which has it set to users blog. So that's where the value is being picked from. Now, when we install the WordPress application with a Helm chart, we did it with a single Helm install command. Now, this command pulls the chart and deploys the application instantly. So there is no window for us to modify the value in values.yaml file. One way we could modify some of the default values is by passing in a command line parameter along with the helm install command using the set option. With the set option, you can pass in any field from the values.yaml file and set a value for it in the command line. This can be used multiple times to pass multiple parameters to the command line to customize the deployment. So here we customize the WordPress blog name property to Helm Tutorials and the user email to john@example.com. And these override the values set in the values.yaml file. Now, if there are too many of these values, then another option is to move these to our own custom values.yaml file. So here we create a file named custom values.yaml, and we then move the variables inside this. Since this is a YAML file, we replace the equal sign with the colon, and we then pass in this file using the values option like this. So -- values custom values.yaml. So this is going to now pick the values from this custom.values file and then override the values in the default values.yaml file. And finally, what if we really want to modify the built-in values.yaml file itself instead of using the command line option or the custom values file? So instead of running the helm install command, we will break it up into two commands. First, we pull the chart using the helm pull command. Now this will pull the chart in an archived form or compressed form, and then you will have to unarchive or uncompress it. Or you could have helm uncompress it by running the helm pull command with the -- untar option in the command line. Now this creates a directory named WordPress. Under this, you will see all the files that are part of the chart. And there is the values.yaml file. We can then open and edit this file in any text editor. And then once we are ready, we run the helm install command. But instead of specifying the WordPress chart name, now we specify the path to the local WordPress directory. So the / here indicates current directory, and it picks the chart from the WordPress directory, which is under the current directory. So when you run the helm install command, you can specify a release name followed by the chart name, which is on the chart repository, or if you have a local chart on your local file system in a particular directory, you can specify the path to that directory as well. Well, that's all for now, and I will see you in the next one. Let's talk about lifecycle management with Helm. Now, lifecycle management can sound like a fancy technical term that's too abstract to understand at first glance. So let's translate it into plain English by taking a look at some practical examples. Now, each time we pull in a chart and install it, a release is created, as discussed in the previous lessons. A release is somewhat similar to an app, but more specifically, it represents a package or a collection of Kubernetes objects. Now, since Helm knows what Kubernetes objects belong to each release, it can do things like upgrades, downgrades, or uninstalls without touching objects that might belong to other releases. So each release can be managed independently, even if they're all based on the same chart. Now let's just create a new release and discuss this as we go along. So we'll install a pretty old version of this Nginx chart. By the way, you can pass in a specific version of Helm chart to install using the version option in the install command like this. We now have an Nginx release, plainly called Nginx release. And now imagine 2 months go by, which is a long time for any piece of software, but especially for a website. A lot of security vulnerabilities get discovered and they need to be patched up. Now, our Nginx hosted website may have many objects in our Kubernetes cluster. When we upgrade the pods running Nginx, maybe we also need to make some changes to other Kubernetes objects. For example, the newer version of Nginx may require a new environment variable to be set or new secret to be created, which requires changing configuration objects and other files part of the manifest files. but it may be hard to keep track of all pieces that need to be changed. Fortunately, as we said, Helm keeps track of everything associated with a release, so we don't have to upgrade our objects one by one. Helm can automatically upgrade them all with one single command. But first, let's see what version of Nginx is running in our pod. We initially have to find out the name of our Nginx pod, so we run the kubectl get pods command to see the pod that we created. Then we run a kubectl describe pod command to see more details about the image, and we see that it's running Nginx version 1.19.2. So that's pretty old. Now let's see a Helm upgrade in action. The command is rather simple, so we just tell Helm what release we want to upgrade and then specify the chart that this release is based on. So we now run the Helm upgrade command to upgrade the Nginx release. So revision 1 is now replaced by revision 2. Note the revision number in the output of the Helm upgrade command. So did the Helm upgrade command really do its job? Let's check. In the upgrade process, the old pod gets destroyed and a new one gets created. So we'll need to get the name of the new one. So we follow the same Helm process again and get the new pod name, then run a describe on it, and we see the new version, which is Nginx 1.21.4. So there you have it. We just went through the so-called lifecycle management with Helm. A release can exist for months or years, and Helm can manage its lifecycle in many ways by keeping track of its current state, previous states, and bring it into future states. So in this case, we brought the release into a future state by upgrading it. But Helm kept a record of the previous state too. We noticed the revision number changing to 2, so the previous state would be revision 1. Now, how does that help us? Let's take a look at our releases. Run the helm list command to list the current releases. And we have our Nginx release listed. We see the current revision number, which happens to be 2. In this case, we know what the previous revision was and what the current one is. But say we work in a big team and lots of people manage their releases, this output doesn't really tell us what happened. So how do we dig deeper? Run the helm history command to see more details about a particular release. This is a lot more helpful. We can clearly see a lot of useful things. What chart version was or is used in each revision, what app version was or is used in each revision, what action actually created that revision, was it an install, an upgrade, or a rollback? So this paints a clear picture of the stages our release went through, its lifecycle history. Now let's assume this upgrade did something that we don't like. Helm's lifecycle management allows for another cool thing called rollback. Now this lets us return a release to a previous state. So in this case, we want to return to revision 1. So in this case, we run the command helm rollback Nginx release and specify the revision number that we want to roll back to, and that is revision 1. Now when you do that, remember Helm reverts all configuration to how it was previously in revision 1, but technically it does not go back to revision 1. Instead, it creates a new revision, revision 3, with a similar configuration as in revision 1. So if you list Helm revisions with the Helm history command, now you will see that there are 3 versions with revision 1 and 2 having the same chart and the app versions, and there is a note in description that says it's a rollback to revision 1. It's worth mentioning that we chose Nginx here as it's simple to upgrade. But there will be Kubernetes packages that may require a few extra steps to upgrade. For example, if we have tried to upgrade the previous WordPress release that we created, we would have got this output. Now, that's not to say that this is a problem. It can be easily solved by adding some more parameters to the command line as instructed in the text. But why does this happen? In this case, Helm cannot upgrade everything without having access to some administrative passwords. It needs administrative access to the database and to the WordPress website itself so that it can get permissions to make necessary changes. It's also worth mentioning that although rollbacks are very similar to a backup restore feature, it doesn't cover file or directory data that may be created by our applications. Instead, Helm backs up and restores the declarations or manifest files of our Kubernetes objects. So, for things that use persistent volumes or other forms of persistent data, or something that is external, maybe like an external database, a rollback won't restore that data too. For example, imagine you roll back a MySQL database server. The MySQL pods will be restored to their previous states, software versions used, and so on. But the actual database, its data, will remain the same. Its data is not going to be backed up or restored. So there are options available to take consistent backups of databases before upgrading charts, or even to roll back or restore databases, but they're done using what is known as chart hooks, which we will discuss later in this course. Well, that's all for now. Head over to the labs and get some hands-on practice. Let's start with writing our own Helm charts first. Helm charts are incredibly versatile and they can automate almost any kind of Kubernetes package installation that we can think of. In a way, they're similar to installation wizards on operating systems. An installation wizard, besides extracting the application files and directories, can also add relevant shortcuts to the desktop, configure the application to launch when the operating system starts up, install additional libraries that are needed, and so on. The same is true for Helm charts. Although charts are technically not programs, they can act like programs. Besides just installing various Kubernetes objects to get our app up and running, they can do some extra stuff too. For example, we can write the chart in such a way that whenever we do a Helm upgrade, a database can be automatically backed up before that happens. So we have a way to restore data from backup in case something goes wrong. And that's just one small example. We will look at those kind of complex setups with hooks and everything towards the end of this section. It can be overwhelming to think about like a million things a chart can do at this point. So let's start with something simple and learn the important bits and pieces one by one. So let's start by looking at how to create a Helm chart from scratch. Let's use the example of a simple Hello World application. We have a deployment with the Nginx image with 2 replicas, and we have a service to expose this application. Super simple. Let's see how we can create a Helm chart from this. Earlier, we learned that Helm chart is a directory with a specific structure, with the templates directory and the other supporting files like the values.yaml, the chart.yaml, license, readme, etc. So our goal is to create a directory structure first, something like this. But you don't have to do that yourself manually. You could run the helm create command and specify a chart name to create a chart structure. And this creates a skeleton structure of a Helm chart. So now you just have to go in and modify these files or add the relevant files to the templates or charts directory. Now you'll see the chart.yaml file already has some sample data in it. It has the name already set to Nginx chart because that's what we gave in the command line, and a sample description and some sample values for versions and app versions. Now let's assume the following scenario. Let's assume that we are building this for our company and we want other employees or other users that use it to have some basic information about the chart. So we'll modify the description and add an email at the end under the maintenance section so people can contact us if they have any questions. And feel free to modify the other details and add other properties to it, such as the home, the URL to the home directory, or a path to the icon, etc. As required. Next is the templates directory. It already has some files that are samples. And these are samples automatically created by Helm create command. For now, we will just get rid of these and just work with the files that we already have for our application because our requirement is pretty simple and straightforward. Okay, so we now have an empty templates directory. And our first goal is to move the files that we already have for our application the deployment file and the service YAML file into this directory. And to be honest, this should be it. Once we place the relevant files in the templates directory, our Helm chart technically should be ready to go. Our chart is now ready to be installed using the helm install command. However, note that these files in the templates folder have all static values in it. For example, if you look at the name of the deployment or the number of replicas or the name of containers, they're all statically defined to hello world, for example. Now, what could be the problem with that? Imagine we install the Helm chart with this using the helm install command. We give the release a name, hello world 1, and point to the nginx chart directory that we just created. It installs the chart and creates a deployment. The deployment is named hello world. This is because the template file has name hello world defined in it. Now, what happens when you try to install another release of the same chart? It fails with the error message that says a deployment with the name hello world already exists. And of course, as you can see, this is because the deployment name is static, is defined statically in the deployment.yaml file. And every time that we are installing a new release using the helm install command, it's simply trying to create the same deployment with the same name. So it must have different names each time you install a Helm chart. So how do we solve this? We templatize the name of the deployment. We use Helm's templating language to basically tell Helm that the name of this deployment should be based on how the user chose to name his or her release. So release.name becomes hello world-1, and the name of the deployment becomes hello world1-nginx. So let's take a closer look at that template. Now we templatize something by adding something between the two curly brackets. This is called as the template directive, and it's not something very specific to Helm. It is in fact the Go template language, the Go programming language's template language. Within the curly brackets is where we specify the path to the objects that we'd like to access. It starts with a dot. The dot refers to the root level or top level scope. We'll talk more about scopes in the upcoming lectures. The release.name in this case is the release name that we have specified in the helm install command. So when we run the helm install command, the template directive is replaced by the release name to form hello-world-1-nginx. So that's how templating works. Now, similar to release name, there are other objects as well, such as release.name, release.namespace, release.isUpgrade, revision, service, etc. Or you can refer to any values from the chart.yaml file that we created, such as the chart name itself, or the API version that we have defined in the chart.yaml file, or the version or type, keywords, home, etc. Or even details of the Kubernetes cluster itself with the capabilities object, such as the kube version, or the set of versions of resources available on the cluster, or the Helm version and such. And anything that starts with the values is something that refers to the properties defined in the values.yaml file. And this could be any number of values defined in the values.yaml file, and currently there are 2. Now, one other thing to note here is the difference in case convention. For the first 3 objects, release, chart, and capabilities, the second part after the dot all starts with a capital letter, such as name, namespace, isUpgrade, and others. However, if you look at values, you'll see they start with a small case. So why is that? These are case sensitive, so it is important to be careful with the case you use. The first 3 are built-in objects, and as such, they must follow the capital letter naming convention. Everything under values are user-defined. That is, whatever user defines in the values.yaml file. So the users are free to follow whatever naming convention that they'd like to follow in the values.yaml file. In this case, these values follow a small case letter. And so you must use whatever it is that is defined in the values.yaml file. Coming back to our example, if we create a release called Hello World 1 and another called Hello World 2, the first one will name the deployment Hello World 1 Nginx, while the second one will call it Hello World 2 Nginx. And we now have guaranteed unique names. Now remember to do the same for the services or any other objects that you create as part of your Helm chart. We should follow similar techniques for all Kubernetes objects that must have unique values or names. Helm does not allow us to install two releases with the same name. So by basing the names of our Kubernetes objects on the release name, we can be sure that our charts can never create two objects with the same name. Furthermore, when we later explore our objects, seeing something called release 5-pvc or something will quickly help us identify to which release this object belongs to. So whatever value you think shouldn't be hard-coded should be templatized. In this case, the replicas and image names could be values that we need to allow the user using our charts to customize. So we can templatize them by using the values.replica count and values.image template directive like this. So anything defined as values should either be passed through the values option or the set option while installing Helm chart, or be defined in the values.yaml file like this. So let's take a closer look at the value defined for image. Since it's text, we could access it within the deployment.yaml file as values.image. Now, image could have an image name and a version number, as well as other properties such as pull policy, etc. So we can either write it as image_repository, image_pull policy, or image_tag. But a better way and the right way to do it is to write it as a dictionary like this. This way, we can refer to the image name as values.image.repository. So values tells the value is from the values.yaml file. The image is the image dictionary within the values.yaml file. And repository is the name of the repository within the image dictionary. So that's how the template directive is formed when we work with dictionaries. And if we want to add the tag on, then we add the tag using the same format, values.image.tag, like this. So the image repository part becomes Nginx, and the image tag part becomes 1.16.0, and together they form the complete value with the colon in between. Well, that's how you define a dictionary in the values file and use it in a template. So to summarize, when we install a Helm chart, Helm uses the files in the templates directory and then combines it with the information about the releases, such as the release name and any other information, the data stored in the values.yaml file, and the chart details to form the final versions of manifest files as seen here on the right to deploy resources on Kubernetes. Now, apart from these, it also refers to any other object that are available, such as the Kubernetes cluster itself. So there may be some data that is pulled from the Kubernetes cluster itself, and any other objects that is available to be used in a Helm template. Well, that's all for this lecture, and I will see you in the next one. Now that we have developed our first chart, let's make sure the chart is working as intended. Now, there are three ways to verify your Helm charts before installing them. Linting helps us verify that the chart and the YAML format is correct. Secondly, verifying the template helps us make sure that the templating part is working as expected. And the third option is the dry run option, which helps us make sure that the chart works well with Kubernetes itself. So let's look at each of these in more detail. So how do we make sure that our chart is built correctly without any formatting errors or wrong values? Say, for instance, while building the chart, we made a few mistakes, such as accidentally not having enough spaces before a line, thereby resulting in an incorrect format, or making a typo in using a variable name, such as a release with two E's instead of an E and A. So what do you do in such case? How do you catch these errors? For this, run the helm2 command and specify the path to the chart directory. This command goes through the files in the chart and validates their format and looks for errors. It highlights the 2 errors and tells us which file and what line the errors are on. The typo error is at line 4 and the YAML indentation error is at line 20. Now, fixing these errors and running the command again tells us the lint is completed and there are 0 chart failures. So you can see that it also recommends best practices such as adding icon is recommended in the chart.yaml file. Now that we have made sure there are no errors in the format of the file, we want to make sure that the templating stuff we added in the deployment.yaml file is actually generating what we'd expect in the final parsed manifest file that it will send to Kubernetes. So meaning the release.name will translate to the actual release name, and the properties in values file will translate to the values listed there. So we can verify what would be generated with the helm template command followed by the chart name. The helm template command renders a chart template locally and displays the output. This output shows us what each template.yaml file would generate, and everything looks correct. The values we defined in the values.yaml file were picked and used by our deployment.yaml template file, such as the replica count and the image name. Also, if you notice, the release name is mentioned as release-name in capital letters. Now, this is because we haven't specified a release name in the command itself. So if you don't pass in a release name, this is what you will see. That's the default release name that it applies when you run the helm template command. So you could pass in a release name in the command, just like how you would pass in a release name in the install command. And then it generates a new file with the release name that you've specified in the helm template command. Now, if there was an error in one of the template files, say for example, it was malformed and there is an indentation error in one of the files, the template command will fail with an error. However, it might not be obvious as to what exactly the error is at times. For example, in this case, the name under metadata is not intended correctly. It might help to see how the YAML file was generated so you can spot the issue, because from the output of this particular helm template command, it's not very clear as to what is the exact file that was generated, which has this particular indentation issue. So to see the YAML file that was generated, which caused the error, use the debug flag along with the helm template command like this, and it displays the generated YAML file in the output. And this can be handy to view what the cause of the issue is. So we have verified that the YAML format is correct using the helm lint command. And we have verified that helm templating is working as expected using the helm template command. And these 2 steps help us catch a lot of errors. However, there are still other errors that we could make that may not be caught by these commands. For example, we made a mistake with the Kubernetes manifest file. So instead of containers, we wrote container in the singular form. Neither the helm lint command nor the helm template command is going to catch this because the YAML format is correct and the templating is correct as well. So what's wrong is the Kubernetes manifest format. So only Kubernetes can tell us that this is wrong. To catch this, we could run the same helm install command that we ran earlier to install the Helm chart, but with the dry run option. So this just pretends to install the package to the cluster, and it can catch things that Kubernetes would complain about in a real install. Once the issues are fixed, we run the helm install command again with the dry run option, and you should see the YAML files in their final format, but does not actually install the applications or make any changes to the actual cluster. This is just going to do a dry run. So this is a handy way of making sure that everything is working as expected before performing the real install. Well, that's it for this lecture. Well, head over to the labs and practice working on building some basic charts and making sure that the charts you build are working as expected. And we will continue learning more about developing charts in the upcoming videos. We now look at functions in Helm. So we saw how a template and the values.yaml file together create a valid manifest file. Now, what if the values.yaml file didn't have a field set? That will create a file without that field. The output file, of course, will also not have that field. So say, for example, the repository name isn't set, so this would result in the resulting manifest file being created without this value. And that in turn would result in the pods failing to be created. So what we need here is a simple way for our chart to have some default values that it can fall back on in case the users don't provide anything in their values.yaml file. So the logic would be if the user provided something in the values.yaml file, then use that. If there wasn't a value provided, then use this default value like nginx, which and we can do such a thing using functions. So what are functions? What do we know about functions already? Now, we've heard about functions in the programming world. Say, for example, we have a string called helm, and we want to convert it to uppercase. In the programming world, we have functions available for it, such as the upper function, and we call upper function and pass in this string as a parameter for an argument, and we get the string in all uppercase. Similarly, let's say we have another string with some spaces in the beginning and at the end. And how do we remove those extra spaces? For that, we call the trim function, and that removes the extra spaces. So a function takes in an input, such as the string helm in this example, and processes it and gives us an output in the desired format. In this case, it helps transform data from one format to another. So what's it got to do with Helm? If we've been discussing how Helm uses the files available under the templates directory and combines them with the information available in the release, the values.yaml file, and the chart details to create final version of the manifest files on Kubernetes. So the template directory values.image.repository gets translated into the value from the values.yaml file, which happens to be nginx. So in this lecture, we will focus purely on what's within the template directive. Now, within the double curly brackets, as with programming languages, functions in Helm help transform data from one format to another. Say, for example, we would like to convert nginx into uppercase without changing the value defined in the values.yaml file. We could call the upper function in the template directive by adding the name of the function upper like this before we provide the repository name. And that converts the value to uppercase in the generated manifest file. Now, in this case, upper is the function name and values.image.repository is the argument. This function has one argument. Another example would be to add a quote around the text. For this, use the quote function, and this adds quote around the text nginx in the generated manifest file. The replace function replaces a character with another. In this case, replaces x with a y. And note that in this case, the replace function takes additional arguments. X is the string to look for, and y is the string to replace it with. So this function has total of 3 arguments. The details about arguments a function takes can be found in the Helm documentation pages. So make sure to always refer to that while working with each function. Another example is to shuffle the characters using the shuffle function. Now, of course, you wouldn't want to use these functions with image names because after all, you don't want to shuffle an image name. And these are just examples. And these are just a few of the many string functions available in Helm. A comprehensive list can be found in the documentation pages, and you'll work with some of these in the upcoming labs. So what we just saw were string functions. Apart from those, there are other types of functions such as cryptographic or security related functions for working with dates, dictionaries, or lists, and Kubernetes related functions, network related functions, type conversion, regex, URL, etc. A full list of supported functions can be found in the Helm documentation pages that are available at this URL. So back to our problem of adding a default value for the image if it's not specified. As we discussed, if the value is not passed through command line or is not present in the values.yaml file, then it won't be present in the generated manifest file as well. We can add a function called default before the image repository variable and specify a default value of nginx. Note that the value always have to be within a quote. So anything that's not in quotes is considered a variable. And so it might complain that nginx is not available. So in this case, since nginx is the string that which has to be the default value, we put it in quotes. So this function will result in the resulting deployment file to always have a default image name of nginx. Well, that's all for now, and I will see you in the next one. Let us now look at pipelines. In the Linux world, when you run this echo command, it prints the string that you pass in as a parameter as output on the screen. However, if we want to take the output of this command and then process it in some way in another command, we use pipes or pipelines. In this example, the output of the first command, echo, is passed through as input to the translate command using a pipe where all characters from the smaller case A to Z are translated to the capital case. Now, we have seen functions in Helm. We write the function name before the variable names like this. But another way to write this, and one that you will see most commonly used, is using pipelines. So this can also be written by moving the function name to the end and using a pipe like this. Both of these will result in the same output. With pipelines, you can now pipe multiple functions one after the other. For example, you can pipe the output of the upper function as input to the quote function. This adds a quote around the output of the uppercase function. And you could then pipe that output to the input of a shuffle function, and that shuffles the output. So now the nginx word is first converted to uppercase, and then quotes are added around it, and then finally it is shuffled. Well, that's all for now. Head over to the labs and practice working with functions and pipelines, and I will see you in the next one.